stretch it out. Stretch it out. All right. Watch the live stream. Is it started yet? Okay. Good night, everybody. Once again, I'm Dan from Dan Does Data, and tonight we are continuing to look at SciKit Flow. Important news with SciKit Flow: it was officially released to PyPy this weekend, so it's no longer merely installed via GitHub. You can now just pip install Skflow, and it'll be done. If you still want the development version, you can of course do that. They're adding new things to Skflow all the time. They're rather active. It doesn't look like they have many issues, but that's because they've closed a large number of them, and they've closed a large number of pull requests. So they've been very busy with Skflow or SciKit Flow. I keep calling it Skflow just because, in my mind, whatever the module name is in Python, the import blank, that's what the name is. All right, last week we got started with Skflow, and this week we are going to continue. And last week, you might recall, we did this cool convolutional neural net model with the image, MNIST image classification, or excuse me, digit classification data set, but we couldn't get at all the weights. We can only get at the weights that are part of the Skflow model. The custom part of the model we couldn't get at. So I want to try to see if I can do that. Also, I want to see if I can pip uninstall Skflow. So that we can install it from the using pip whatever. Excuse me. Oh, really? That's interesting. Yes, proceed. Now let's try. So we install the latest version from PyPy, just to be pedantic. If I sudo that, which I really shouldn't do, but that's okay. Okay. So now we have Skflow once again. Life is good. Let's double check that this works. If it doesn't anymore, then the rest of the video will be me fixing my Skflow implementation. Alright, it imported, no problem. We got some matplotlib stuff, just because that's what we like. Alright, so the goal tonight is going to be to get the weights out of our convolutional model. And that's, we've got this hconv1 and hpool1. Those are the elements of our layer. I guess it's skflow.ops.conv2d is sort of doing that in its own right. So maybe I need to return not just the model, but also the functions, those layer pools themselves. Just as a reminder, let's just rerun the model just so we remember what it does. First we import, well, we already imported Skflow and sklearn and matplotlib to do some cool pictures. Let's import TensorFlow along with its tutorials.mnist. Let's get that data set going. That's a 6, that's right. It's always good to plot some of your data. Do a simple, this is a 3 hidden layer deep classifier right here. Just something simple right here. That might take a little time. You verify that the loss function is going down. You say excellent, that's good. It's gone through the data once, twice, 3 times the charm. That's getting better. I'm probably about to say that's good enough. I don't need to go through that a whole bunch. I just want to see what's the score. It's 96% accuracy. We can take a look at those actual weights on the, I think, top layer here. Is that what we're looking at? Yes, at the top layer. where we've got 100 nodes. We organize them into 10 by 10 grid of images here. And that takes a little bit of time, and you can see that, and you get some interesting different features. Make that bigger. Let me not crash my machine. This is 10 by 10. It's 100 times 784. So there's a lot of different pixels it's plotting. Shouldn't really be that hard, but for some reason it is sometimes. So there's some interesting features down here in some of these, and some of these are sort of random. But we looked at that last week, and that's kind of interesting. Shrink that. Yes, and then what do we do here? We plotted across the layers themselves. Excuse me, I thought I clicked that. I think we killed our Python. Hang on. Might be okay. There we go, we're back, okay. Danger of that plotting matplotlib. Right. We were looking at the classifier weights on each layer, just a little more compact. This wasn't particularly informative, other than in this first layer, perhaps. Oh no, there's like 8 times as many as in these other layers, because you got 784 going into 10. Here you got, or going into 100. Here you've got 100 going into 100. That's why this looks much more gray. It's just more squished. All right, we're going to redefine the convolutional neural net. So you got the pooling, of course, which takes the output of the convolution and looks for big features in a group of 4 that are next to each other and says, hey, take the biggest one out of those 4 for a given feature. The actual convolution, in this case we have 2 convolutional layers, so you take that n by n sub-image and you're computing a whole bunch of features on that, in this case 32. So it's like a little smaller component to your neural net. And you do that, and then you do that again, essentially, based on the output of those previous interesting filters. You drag this 5 by 5 window all around. All right, then you can classify as before. You can say, I've got an Skflow.TensorFlow estimator, very generic, and you can pass it this model. That's my conv model. And all this model is our 2 convolutional layers, and then a regular deep neural net that just has 1 layer of 64 nodes. It takes as input whatever this hpool2 flat business is, and the output. Oh, and then we do logistic regression with that, the output of that neural net, with given our predictions. So we can do that here, and I suspect we couldn't get at the weights of these layers, this convolutional layer and this convolutional layer, because they're not part of this deep neural network object. All right, we built our classifier. Let's fit it. So it's cranking now. Step 1, whatever. I'm not too concerned about getting a super good model right now. I just want to be able to get at those weights. If we can get at the weights, then we can see what they are and hopefully learn something useful about the model, other than like, oh, it does so good, such and such good. It's often really helpful to look at the weights and see what it's really doing. Oh boy, that's long. That's taking a while. Let me redo some of this. That's probably not going to change anything. There we go. Okay, a little faster. At least in giving me information. All right. How many mini batches am I going? Still going down, still going down, still not, oh, went up. That's not so good. All right, and then it decided it was done. How good is it actually? Probably pretty bad is the answer. Accuracy, 20%, whatever. It's fine. It's not a thing. So classifier, but the catch is before we actually had a classifier.weights underscore object. We don't have that anymore. So that's but if I say classifier.modelFN what's this? That just returns the actual function that I used here. And it might actually be possible to get at components to the function. Oh, come on. Conv model dot. I thought if you use the inspect module, maybe you can do fancy things with a particular. Inspect is a module in Python that lets you sort of go deep into the source code and pull out things you might not normally be able to. Actually, yeah, underscore is sort of the indicator in Python that methods or attributes are private, but it's not enforced. If you can look at anything essentially. Trainer, session, restore, predict, module. See, because if I say model function dot and it says there's nothing, but if I say underscore, turns out there's a lot of things that come along with being a function. For example, code. Code object is not callable, right? Well, but there's like CO names or something. There's a way to like steal the source code to things. Oh, dot name. You can get the name of. Yeah, so you can actually get the name of a function that you call. That's kind of a cool thing. That has nothing to do with TensorFlow nor Skflow. Just a cool thing here. Dot steps. Number string to it. No, that doesn't. Dot predict prob A, predict partial fit. Learning rate, get tensor. What about get tensor? Name string or name of tensor. There's like a particular way you're supposed to use this, I think. Yeah, I tried this last week. Refers to a tensor which does not exist. Get tensor value. Alright, so here's where we search on the internet now. Skflow. Model weight. Inspect.get source. Yes, that is what I think I was talking about. I don't believe that's actually going to help me here, but it probably lets you do dangerous things that you really, if you're doing that, you're probably doing something wrong. Not necessarily, but it shouldn't be something that you have to do. Class weight support, issue number 57. That might be correct. It might just be that this isn't something you can do with Skflow yet. I think I've looked at this before. No, that's a question about imbalanced data. Weight loss tips. No. Every time I was searching for this before, and I also came across like weight loss tips, and it's not. No, that's not what I'm trying to do. Oh, internet. Low weight hub bearing unit improves all this stuff. Not what I want. Alright, what if I say, I'm really serious, I mean Skflow. Nothing like Skflow, just Skflow itself. Alright, so we're going to keep exploring. Skflow, get tensor. What does it say? Name string, string of tensor. Self.get tensor by name. Self.graph. I didn't know that was a thing. What do we got? What are our options? Graph. That might actually be helpful. Name scope? I need a list of the names so I can see what I can. Doubt that's going to be what I want. Also, scape is not scope. Bound method, whatever. Missing required argument. Name. FC1 maybe? Let's see what it says. Context.generator context. I don't understand this. I don't understand this at all. So the catch is I need weights that are sort of come out of an object such as this. Presumably, those are things that somewhere they exist. But I can't do all this, excuse me, I can't do all this outside of a function because I need to pass the function into here, into our skflow.tensorflow estimator. TensorFlow estimator, maybe it'll tell me a little more here. Takes input XY tensors, output prediction and loss tensors, yada yada yada. Empty string is default, number of steps to run over data. Maybe that's the epics. TF random seed, continued training, cores, early stopping, max to keep. Keep checkpoint every n hours. That's not really what I'm doing. Class weight. None or list of n classes floats. Weight associated with classes for loss computation. I'm not kidding. All classes are supposed to have weight 1. Oh, so you can make some classes of the output more important than others. I apologize that this isn't a more exciting video. I'm a little irritated that there's not an easy way to get at the weights. Maybe I should just search Skflow TensorFlow estimator. Maybe there's an examples. There's something here. TensorFlow estimator. All right. Test saver, linear. They do something with digits here. Let's see. What do we got? What do we got? Estimator. Dot restore path. Yada yada yada. Test custom model. Saver test. Do they have weights anywhere? No. Accuracy. Estimator. Estimator. Just a regular classifier. Nope, nothing there. Any weight? Alright, we got some matches here. Get tensor value. Hang on. This might be a winner here. And they say linear regression because linear regression is presumably defined somewhere else in here. Linear regression. Models.linear regression. What's models in this case? Skflow import models. Interesting. So skflow.models. Oh, hey, logistic regression is the thing that I have. Okay, so maybe I could say classifier. Dot. What's the magic? Get tensor value. That's what I need. Get tensor value, and it's going to be logistic regression slash weights. Like, this is a very arcane way. Let's see if that works. Hey, we got something. All right, that's a good start. Let me save that into W for a second and see what we really got. I suspect these are just the output weights. The weights sort of in the final layer. So after the convolution, after the single layer, the hidden single fully connected hidden layer, this H fully connected, the weights from that to the output logistic regression. So this should be 64 times 10. So if I say w.shape, you do in fact get 64 rows with 10 things each. So that's interesting. And we can let me take a look at these. That's not what I want. I just want to plot these, I guess. Yeah, I guess that's just what I want to do. Plot.pcolor. That's what I want. W. This isn't super informative, just looking at it like this. These are your 64 different nodes, and these are the different output classes. But there's no obvious patterns because it's just a fully connected layer, so it's not Not generally going to be super clear that there's anything going on like that. But we got somewhere, so that's good. Let's say CMap equals plot.cm.gray. So see if that makes it any more clear. Sometimes colors are better, sometimes grays are better for me. Sometimes making things a little more square is better. Alright, nothing super obvious. Alright, but can we get at these interior, like pulling out the convolutional layers is really what we want to do. So really, classifier.get tensor value. And I called logistic regression essentially weights. So do I want, like, it's not the name of this thing. It's like the name of this thing. Sort of, not really. Maybe there's more than weight 0? Maybe there's more? Logistic regression / weights 1? It's probably not going to work. Yeah, refers to a tensor does not exist. The optimization exists, but only has 1 outputs. What about this? What if I just say, give me all the ones logistic regression? Okay, never mind. Just weights. Weights 1, weights 0 is the only one that exists. Alright, that's a bummer. Okay. So the question is, how do we get the other names of things so we can call this get tensor value business? That's sort of the frustration going on here. Here they just call linear regression. They don't do anything fancy. Weights. Weight 0, bias 0. So that ends up being a wash. What about this? What about this? Weight. That's estimator. So I want to search really get tensor. Oh, you're not helping me, pal. I know there's more things in there. Get tensor name, numpy ray, value of the tensor. No. I know there's a get tensor value. Don't you lie to me. Yeah, you should have shown me all the get tensors when I did this. Okay, maybe this is interesting. Skflow to estimators at RNN. That's just logistic. All right, how do I dig deeper? Here we go. So DNN, layer, linear, matrix, whatever. So if there's a deep neural net, as there is here they've made a cool model function. Where is it? Self.model function. That's cute. Super. TensorFlow DNN classifier. Okay. Oh, this is defining the DNN classifier. All right. Let's keep this in mind. Where was I? Here. This. Weights.append. We got DNN, because we do have a deep neural net over here, this thing. If we can pull those out, we're slowly working our way back. Gonna get there eventually. / layer 0, I'm guessing? Rare and yeah, there's gonna be a layer 0, sure. Layer 0 / linear / matrix? Let's see if that gives us something. Hey, what do you know? So what is this? 3,136 by 64. Okay. And I bet 3136 is 7 times 7 times 64. Just a guess, as that's the input here. So in fact, 49 times 64 is exactly 3136. So these should be exactly the things we're looking for. Let me just make sure these look like things that are things. W1, we're ignoring all the obvious structural, that these come from groups of pixels that are next to each other when we just do this, but this is just to see, okay, yes, those are weights, they're various things. All right, now we're getting somewhere interesting. So I want to start saving this information now. This subplot isn't exactly what I want. But we do have typically this number of rows by number of columns. In the final layer, it's 64. So it's 8 by 8, we'll say. It's the final layer. And that's classifier.w equals, there we go. Classifier.get tensor value. Logistic regression. So it appears that it's probably going to be possible, just kind of a silly pain to get these things. So this is just going to be W. How did I plot those? Because W is just 64 by whatever. All right. Plot.pcolor W. And I don't even need this. And I don't need that. But I'll grab all this. We'll paste it down there. Get rid of that stuff. There we go. Okay. Now we're getting somewhere. Because now we're going to do W1. And we're going to say W1 is all the things. All the things. And of course, I'm working backwards up from the end of my network, but that's okay. That is totally okay right now. No problem with that. Because we have some of the magic words that we need to pull out the weights. And probably what this means is that we'll just have to go into the TensorFlow documentation and source to figure out exactly how to pull out the other ones. If you're in pure TensorFlow, you can sort of just inspect whatever variable you stuff those weights into when you're doing the convolution. But because we're using Skflow, we sort of waved our hands around that. We used skflow.ops.conv2d to ignore a lot of that. So if we did ops.dnn, probably there's a conv2d layers, probably layer 0 or layer 1, or hey, conv layer 1, hey. That might be the magic kind of thing that we need to activate there. All right, but we're still plotting. That's always the catch here. W1.shape is again this, yes. And the output is 64. So every row is a 7 by 7 object here. So I want to look at my 64 different features as they come in groups of 7 by 7. Make sure we follow along with that. Okay. SX, XY. We've got W1, but not W1 of 0. W1 of all the things I want all the rows, comma, in just the yy times 8 plus xx column. And we need to reshape this into 7 comma 7, because that's what the output is of the convolutional layer. Let's just try that. Verify that business works at all. Always good to do. W1, all the rows of yy times 8. This is of course 0 in this case, but that's okay. And we'll learn whether I can remember how to use reshape or not. Chances are no. Total size of the array must be unchanged. Yeah. What's this? Dot shape. 31, 36. But, oh, I just happened to be passing in 64 things here. My mistake. I got this 64 confused with this 64. Right. But in fact, I have 64 features going to 64 different nodes. Okay. So let's just pick one of the output nodes that we're looking at. Doesn't matter which one, we don't really care. So let's just look at the first one. And let's look at what we're passing into that. Let's see, dot reshape. And now here's where I hope that I'm pulling them out in the correct fashion here. We'll find out if I'm not. And this is going to be, hang on, oh no. I need to end up with a 7 by 7 image here. So if this is a 3-dimensional guy, and I just said give me, yeah, this is correct. Yy times 8 plus xx. There we go. This should be the correct type of object. And we should be plotting 64 of those little features, little 7 by 7 grids here. And y is not defined. That's because I can't type. A common problem. Okay, let's try that one more time, shall we? Much better. Okay. So those are sort of the 7 by 7 groups of features that are getting sent to the first node of our hidden neural network. And there's nothing obvious here because these features are agglomerations of other features. What I want to do is stuff whatever those other features are into these boxes, and those features will be appropriately weighted by these weights. So you'll get a much larger image, and you'll get something hopefully interesting and maybe human interpretable. Here, it's just like, these are kind of random. Then again, this model isn't very good yet, so maybe they should be kind of random. Although, to be fair, a 20% accuracy is probably better than random if there's a uniform, if there's the same number of digits in the training set of each type of digit. Because then you'd expect your random, 1/10 of the time you just happen to be right. Because there's 10 different kinds of digits. So, 20%, that's twice as good, right? Well, maybe not. Okay. That was for this deep neural net layer. We really want the convolutional layer pieces, particularly this first one, because those you can sort of interpret like, oh, this pixel is being read in this way. These group of pixels are being read in this fashion. So let's see if we can figure out how to do that. What if instead of saying that, I say conv_1? Is that something? No, that's not nothing. Refers to a tensor which does not exist. Does not exist in the graph. Okay. Maybe I don't need layer 0 here, because that's not a thing, perhaps. Does not exist in the graph. Alright. Alright. I guess let's do conv layer 2 while we're in the neighborhood. Can I just say conv layer 2? Is that something I can say? Looks like an invalid operation name. Maybe there's no linear component to this? Does not exist. Does not exist. Yeah, that is the catch. Let's do a little TensorFlow get tensor value. Oh gosh. Find the value of a tensor object in TensorFlow, basic usage, bunch of other stuff on Skflow. So it's primarily used in Skflow, it looks like. Get tensor, let's search here. Get tensor. I love it when the thing I search is not actually in the page. Okay, never mind. Get tensor, you know, here it really should be though. This is basic usage. This is, oh boy, oh boy. Overview, computation graph. Alright, just where's the full documentation? That's really what I want. Oh, there's our 0.7 now. Fancy, fancy. API, I guess. There we go. All kinds of stuff. Python API. Show me everything. Is this everything? This might be everything. Get tensor. Really? Come on, come on. Is it not part of regular TensorFlow? Is this a special part of Skflow? Is that the problem? Like, if I can't get the weights of my interior of my customized pieces, that's kind of frustrating. And these aren't even heavily customized, right? Like, I'm building up different pieces and adding them all into one Skflow thing, but I'm using the Skflow ops conv2d the whole time. I'm using this max pool, which is part of just regular TensorFlow, but none or list of n classes floats. And it would be nice to get a list of what are the possible tensors I can screw around with, right? Like, get tensor list. That would be great. Oh, get params. Yeah, that's what I want. Nope. Yeah, that's not what I'm looking for. Keep checkpoint, params, continue training fit, class weights, yada, 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 yada. Model loss, initialized graph it was doing stuff with. Unique name, seed, name, scope. Like, what is name, scope? What does this mean? Returns a context manager, creates hierarchical names for operations. A string not ending with slash will create a new name scope. Not ending with slash. Interesting. This might actually be helpful. Because we use variable scope, maybe I should ask what that does. TensorFlow variable scope. This turns out to be a video where we do a whole lot of nothing, but that's okay. Sometimes that happens. Understanding variable scope example in TensorFlow. TensorFlow variables, how to. Variable scope. There we go. And then, can you get your hands on param later? Is that a thing you can do then? With variable scope train? No, that's just when you have different variables in hand when you do that, I think. is all it is. Although this is using model. Model gets used in cost. Then you make your session and initialize it. This is train op is of course used in cost, and train op is used in the session in a different scope. Mechanics. Scope. Variable scope example. Consists of two functions, creates a return variable with a given name, manages namespaces for names passed to tf.getVariable. Alright, sure. See how tf.getVariable solves the problem discussed before. Let's refactor the code. Created one convolution into a separate function named conv_relu. Alright. Weights equals getVariable weights. Bias equals getVariable biases. From the kernel shape. Like it to use it for both conv1 and conv2, but the variables need to have different names. So you just have different variable scope, and then you call it the same thing, and you've got a different variable scope, and you call it the same thing. conv2/weights. Alright, hang on. So maybe conv2/weights. Ah, almost. I thought surely I can get away with that. That's gonna say that doesn't look right. Yeah. Layer 0/weights. No. Linear/weights. Matrix/weights. Yeah, this is. I need a way to see what are the options. What could this possibly be called? If I just knew the, what is the standard? How are these things even called things? Then I could very easily understand what I'm supposed to input. Without knowing that, like it's probably conv2/something, presumably. Get variable. How does variable scoping work? V equals name foo/v. See there, we're naming a variable v under foo. But we don't name these things here. They're just in a particular variable scope. What about conv_layer? What about conv2d? Yeah? What about that? Which does not exist. Does not exist in the graph. How can I see what's in the graph? That's a good question. How about that? TensorFlow, examine graph. Maybe that's what I need. You have a graph that you've trained yourself, yada yada yada. I don't want to print the value, I just want to see what all the graph things are. What is the graph doing? That's all I want. Classifier.graph. .seed, name scope, device, finalize, create op. Can I print the graph? Is that something I can do? No, not appreciably. What about TensorFlow? What if I just print the graph? Basic usage, building a TensorFlow graph. TensorFlow disappoints. People have different versions. Train.write graph. That's interesting. What does write graph do? I don't even have that as a thing. tf.train. .graph. Version. Okay. Seed is going to be 42. Unique name. Bound method of something something. Can I say conv_layer1? Is that a thing I can do? conv_layer1. I have a feeling. Yeah, okay, I can get whatever I need. Ah! Okay, because I put in conv_layer1, which is this thing, and it gave me sort of an appended version of that, right here. And when I said, oh, unique name, some random string of letters, and it gave me back exactly what I put in, you put it in again, then it appends this stuff to it because it's sort of stored that. So convlar1 is definitely some kind of useful name in the graph. Get operations, maybe. Maybe that's what I want. Get, like, I want to just get tensors. Show me all the damn tensors. Get operations. That is not helpful. That is not helpful in the slightest. I have a whole bunch of operations now. Wonderful. Wonderful, wonderful. Okay, so get operations. Maybe not what I wanted. As graph def, as graph element. Obj. I don't know what that should be. As graph def, as default. Used if you want to create multiple graphs in the same process. No, I don't want to do that. As element, as as graph def. What does that get used? Turn to serialized graph def representation of this graph. All right, well that sounds helpful. I say it sounds helpful, and it's just not. List fields. Maybe we're getting somewhere now. No, that's not particularly helpful. Because that's a whole bunch of nodes that I can't actually see with any obvious way. What are my options here? Has extension, has field, library, version, set and parent. What if I just want visualize graph? TensorFlow visualize graph, maybe. I don't want to build the graph. I want to visualize the graph. This shouldn't be rocket science, right? Graph visualization. And I shouldn't have to use TensorBoard to just get like a half decent like list of the names of the things in my graph, right? Graph visualization. So it's supposedly they have a graph visualization thing here. Yeah, so this is clearly generated with something, probably TensorBoard. Do they explain how to do that? Oh, well, they do this. All right, what if we save some junk off to logdir? Shall we? And then we'll try to use TensorBoard, even though I have never in the history of time gotten that to work. All right. Although I really shouldn't have to use TensorBoard to do this. That's silly. Doesn't make any sense. All right, we're saving up off some stuff to the local logdir. It's all good. Saving off a little bit. Cost function is going down a little bit. It's pretty slow. Still going down. Still going down. All right, that's fine. Doesn't need to finish too much there. All right, and then we TensorBoard this thing. cd proj / TensorFlow. Got a lot of stuff in here. No, I don't. That's okay. Logdir / Let's see if TensorBoard. Nope. Doesn't like that. Sudo pip install base HTTP server. I think this is why I didn't like TensorBoard, because there's no such thing as that module. That probably changed from 3.4 to 3.5 in Python, which is that's something annoying. Let me just check that real quick. Real quick there. if I could get TensorBoard to work one day, that would be a wonderful, wonderful thing. Actually, maybe the latest TensorFlow actually has that. Pip installation, do they have? They do have 0.07. Required packages. Do they have base HTTP in here? But they're claiming that they don't need it. What changed in 0.7? That'd be good to know. And is it out for 3.5 Python? Come on, come on. Why? Oh, Jesus. No, well, for some reason, can't scan over on their website like that. For reasons, presumably. There we go. That's Pi 2, Pi 3. None, yes. You see, you don't need to list the Python version. So that's a plus. Glad that they have that GPU and CPU, so I'll have to try that again at some point, but not today. Could not find a version to satisfy the requirements. Actually, let me just check. Let me check its actual... No, that's not what I want. Over here. Let's look in their actual repository for base HTTP server. 6 is where it is. I see. Interesting. Oh, so that's something they forgot to update to Python 3. It looks like. I see. I see. Alright, but we shouldn't have to use that to look at the graph. That, if you do, that's absurd and that's frankly wrong. And this is something I can't parse on my own. So that's real cute. And I don't think I'm going to install TensorFlow in the next, in 10 minutes here. Tempting though, that is tempting. If I pip uninstall TensorFlow, I'll do it, I'm doing it. I'm going to try, sudo. I'll try it. And we'll try to install the latest one. This is the most dangerous thing. There's no reason I should be doing this. But whatever. Freaking. And I have no idea why. I'm going to use the GPU version because I can. Sudo pip3 install -- upgrade. Yeah, there we go. Let's try that. So we're installing totally new TensorFlow. Gosh. All this to get TensorBoard so I can see what the heck the graph looks like, so I can get the name of whatever the magic variable is, so I can look at the weights of my convolutional layer. That's TensorFlow. Why? No, you didn't need to install NumPy. Why would you do that? Why would you do that? That was not necessary. I already had NumPy. I really hope this doesn't screw up all the rest of my install. Like that's, you know what? No. You do not need to upgrade. You already have NumPy. There. Checking for NumPy. Using cached NumPy. Sure. That was my own fault. Should not have put the upgrade flag in there. Building wheels for collected packages, NumPy. Alright, fine. Alright, that might be the end of this video, unfortunately, since I now am reinstalling TensorFlow. And that might just be the end of it, as things tend to go. I was talking with sysadmin today about installing TensorFlow, and it's just, we were able to get it to work, but it's a very fragile setup. And I will be very happy as this library matures and it becomes a little more straightforward to install and set up and doesn't require quite so much fiddling. and when it works with a greater class of GPUs. That'll be nice. And see if this goes anywhere. Come on, come on. Dash dash no depths. Oh, you're right. That's what I should have done. I should know that better than that. Because I installed TensorFlow on Sage Math Cloud. And you have to say things like this. No depths, no index. Just here's the wheel file, install it, and it works fine. All right. Let's just let's see if I can still do anything at all. Segfault on Skflow. Probably because I need to reinstall Skflow. Sudo. Yeah. What? You don't need to install NumPy again? Really? Really? I don't think it needs a new NumPy. I really don't. But I could be wrong. It might need the new NumPy, which I think would be strange. Requirement already satisfied. Use upgrade. Yeah, sure. Upgrade. There we go. Requirement already up to date. I disagree. Uninstall. It might need new NumPy, and I might just. It's going to take time, which is annoying. Lots of fun here. Proceed. There we go. Uninstall that. Now we're going to install this. Now we're going to try this. And if it needs new NumPy, it needs new NumPy, and that's life. And it might just need the new NumPy. Alright. So we'll just do that. SciPy as well. Oh well. Alright, so I'm probably going to be spending the rest of the video just downloading that stuff. Running setup.py bdist wheel for NumPy. That's I'm very surprised. I don't know what changed from NumPy 1.8 to 1.10 or how pervasive 1.10 is. But depending on an up-to-date version of NumPy is the least of my worries here. Already up to date. Scikit learn. Excellent. So, what always means that. So that's probably all we're going to get to today and this week, because we are attempting to reinstall TensorFlow just to get at TensorBoard, to get at whatever the heck the thing is called in our graph, to get at the weights using this runaround method of getting that. So that'll be a little bit of time, and that's okay. It is what it is. Next week we'll be back at it. We got some more of the weights. We did. We were able to visualize the at least the weights of the deep network, the deep neural net part. It's not really deep. The parts of the DNN, this thing. So these 64 weights going into 10 classes, we were able to visualize those, so that's a plus. Or, excuse me, we were able to visualize those, so yes, that was good. And we were able to visualize the output of the convolutional layer going into the deep neural net layer. So that is progress. I would have hoped that it wouldn't take an hour to figure that out, but it still doesn't seem super well documented. It just seems like that's still something that we're trying to figure out. But that's okay. I'll be back again next week, probably with more Skflow. I might switch to like another high-level wrapper like Keras or Lasagna or something like that. So subscribe or tweet at me. I'm on Dan Does Data. I'm usually on the machine learning subreddit as well. Say hello. Tell me the things that I did wrong, which I'm sure there's plenty. Tell me the new libraries that you want to see, all that kind of stuff. And thanks for watching tonight.